Now let's move on to reflection in a line. So we are done with the translation. Any question? How to use the translation group to determine images and also how to apply it onto a given graph. There's no question, right? Alright, so let's look at the reflection in a line. So can I bring this? Okay. Reflection in a line. So we have the theory of reflection. So we have been using the aspects of the reflection concept always in our daily lives. Right? What is common to us is the mirror that we have been using in our rooms to dress up. Okay? And what makes this mirror look so special under the concept of the term reflection? Whenever you want to see yourself again, you tend to visit your mirror for your mirror to describe who you are to you. Isn't it? Somebody tells me on the roadside, today it's beautiful. Okay, you really want to rush home for your mirror to confirm for you. So after the man, you look at the compliment. So this mirror is serving as a particular purpose. Mostly telling us how we look like. But we have special properties concerning this mirror. Okay, so as we being original objects facing in front of the mirror, there are some properties that mirror objects to us. The distance that we have to the mirror will correspond to the same distance our image creates with the mirror. Okay, this is one of the properties you can observe when you look in the mirror. And you see your own self again in the mirror, but the only difference is that you will be projected. Hope you understand. You are going to stand in the opposite direction. So in a normal sense, whenever you visit your mirror, you have seen your back. That's the normal sense. Hope you understand this. Yeah. So when you visit your mirror, you have seen your face again. You have seen your back. So seeing your face again tells you that you have been turned around, you have been projected. The mirror has changed your direction. So this is the concept about reflection. This is the concept about reflection. But the only effort this new is whenever you look inside a mirror, whatever that you see is true. The mirror will not give you makeup. The mirror will not give you makeup. The mirror will not make a nose to you. As it is, so shall it be that the mirror will be to you. But the only property that you take note about is the inverted part of the object we are looking against the mirror. Apart from that, your distance from the mirror is the same distance from your image in the mirror. And your own self is the same thing as what you use in the mirror. So we are bringing this reality aspect into mathematics. In this case, we are not going to the market to buy any mirror. Our mirror is in our book, in our graph book. We have to see ourselves through from our graph book. Yes. And that is the axis that we form in our graph book. So we have the first mirror to be our x-axis. So whenever you draw an x-axis, you can stand on top of it, you can see a unit. By observing a unit, not in reality aspect. Are you okay? Yes. By observing a unit. So as our y-axis can also serve as a mirror in any figure or points. By observing a unit or now let's look at some of the rules that can be given in the reflection concepts and see how we can apply some of them in our graphs. So let's look at the rules here.
Hey guys, welcome back. I know I've been going and returning. It's because my, gadget, we have to charge. Sometimes it breaks down. I have to wait for a while before I come back again. So for those of you that are joining for the first time, we are live in Agri Memorial in Cape Coast, and we are here to support our brother. My Ghanaian brother is going on a 40 hours teaching mathematics lesson. Yeah, that's what we're here for. We are at Agri Memorial in Cape Coast, okay? So make sure you share the video. Yeah, if you love education, if you love seeing things like this, share the videos to people who think they would love to see this, okay? Yeah. He's about to make Ghana proud. We just hope and pray that he's gonna win. Yeah, and he's taking it from a Nigerian. So I heard that the last person that got the Guinness Book of Record is a Nigerian. So he's taking it from him. Yeah. So enjoy. Okay?
So when they ask you to reflect a given point in the line, why positive, it is not why outlet they are talking about. Why has been taking off, that is why they are creating the which they are talking about another one, which they have not even mentioned. So this in the line y equal to 0 also means in the x-axis. Are you okay? Then it has a given, let's take that one. Even let's demonstrate this on the graph so that you clearly can by yourself. Let's assume, so we are talking about reflection. So we have our x and y mirror here. X and y mirror. So this is our y mirror. And this is our what? X mirror. So always, whenever a partition plane is drawn, always we start from the quadrant which creates both the x and the y axis or x and y coordinate positives. That's where you always stand to perform any activities afterwards. So we are taking this particular slide here, which makes our given point all positive, both the x and the y axis. So let's assume a given point x1. Let's assume a given point what x1 at this particular pattern or place. Then we are talking about x-axis. So what is the immediate On where the immediate x axis leading to our given point xy, where can it be found? We have two of the x axis that we can consider, but always look at the one that is closer to the point we are talking about. Okay. So over here we have x, one of the x, and because we have divided 1 year, 1 year. This one is far away from this, so we have to just be directly like this. Mirror, we don't go and pass anywhere fast, we go and observe the mirror, just get closer to it. So this serves as a mirror, so this is our mirror. Then standing here to see ourselves, where are we going to appear? Here, down, good. So if my point tends to appear here, then our position retain the same, but its location is same according to the nature of the plane we have done. So over here, which one is going to change? Y. And it's going to do what? Exactly. So you are now telling me the formula. I am not giving you the formula. So the reflection in the y-axis or in the line y equals 0 or x-axis has been given there. That is the formula now that we are going to obey whenever a person is given to us. So the original point given up there was xy, mapping onto a new location that also gives you another point was x was negative y. That is it. So that is the formula for reflection in the line y equals 0 or x hat. Are you okay? Let's also look at the other axis. Reflection in the line x equals 0. That means in the what? Y axis. Come and help us with the formula. Demonstrate on the graph and tell us what the formula is, right? They come and write it down here for us. Are you done? Okay. So the same point, and we have used the y line as the mirror line to reflect to this side. That will give us the nature of what we have here. So we have the x to be negative like this side, y positive, and that gives us our formula. Alright, so we have reflecting the x as this formula reflecting the y axis. Okay. Alright, so let's look at the other formulas that can be given to us. But the most familiar ones are these two that we just talked about.
Guys,
so let's look at
10 hours gone. And we are still waxing strong. We are still here, we are strong. Keep praying for us, okay?
Or you can also say x minus a.
It's not easy. Oh.
So our original point, so this one, we are not demonstrating it on the graph. But the rule says that whenever, so the k is a constant, so any number apart from 0, any number apart from what? 0. So start from 1 to above. So whenever they ask you to reflect a given point in a line x equals to 1, x equals to 2, x equals to 5. The general rule says that you are going to get what? At the side of the x axis, 2k minus x, then y. This is the rule. Okay, this is the rule. So you apply that constant given to you to also take effect of the x coordinates. The rule says 2k minus x maintain the same y as it says in the question. Then also applies to, so let's reflect this to the y aspect as well. So y equals to k, or you can write this as y minus k equals to 0. And this one also the same. So if we are expressing the x coordinates in terms of that k, when they are also talking about the y, do the same thing as the y coordinates and maintain whatever x that we have there. So over here we have xy map to. So can you help me with the formula for y equals to 2? X? Yes. Convert on the x concept and use it for the y. Yes.
X and the y coordinates 2k minus y.
Very good. Let's clap for me. Hey, the clap is very boring. Let's clap for me. Thank you. So x, then we have 2k minus y. So this is a rule concerning progression. Let us also talk about another one. We also have y equals to kx. And the rule says that xy will map to 1 over ky kx. So we have another rule like this. We have lots of rules concerning reflection. Few of them are being used in our examinations, or most of the exam problems that we find it. Few of them are being used. Mostly the number 1 and number 2 are the fluent ones that we normally use. In the special cases we add the number 3 to it, but the rest of them you just have to know the rule and you apply it when you further your education. Let's also talk about the number 6, the rule for number 6. Y equals to x. So this one you can see that they are extending the position of y and x. So you just have to extend their coordinates. So x, y will be mapped to y, x. Okay. So when you get a question like this, find the image of the point with the reflection on the line y equals to x. Then our rule says that if x, y is given to us, then our image y, x change the position of the coordinates. Okay? That was it. And the last one, number 7, y equals to negative x. So what's the image? So x, y, map to very good, negative y, negative x. That's it. So copy this rule down by 3 places in the near future. And we start applying the rules using our examples. Let me give you one thing to write in the conclusion. So let's continue with our first example. Can I clean the roof because the board is full? So get your graph, go straight. Alright, so let's look at this question under reflection. We're going to use our graph to answer this question. Using a scale of 2 centimeters to 1 inch, draw x and y axis for the interval x greater than or equal to 0 but less than or equal to 8. And y greater than or equal to 6, less than or equal to 6. Then you plot the points given here A, B, C, and A, B, and C, and describe the triangle. Describe the triangle means after drawing, you need to be able to name the triangle that you are making to draw. Then find the equation of the point AC. Then you also draw the image of that given triangle that you have already. Let's follow what has been given for us to get a very nice graph. So from the scale, let's look at the scale and use it to draw the diagrams we are giving us. Now for the x-axis, you say it starts from 0 to what? Positive 8. We need to manage this graph. Change the position of the y-axis so that we can have enough space for the positive side of the x. We'll come back to that one. And the y has all the positive and negatives. So that one. So let's try and manage this graph. So we are not going to divide the graph into equal parts. Okay? Because of the nature of the range we need to ask for the x-axis. Do you get what I'm saying? Okay, so we need to move the y line to cover up some of the negative portions concerning the x-axis. Okay, so for the x-axis, we have this line, and we are not dealing with any negative in the x-axis. So let's write the rest of the positive values for the x-axis. 1, 2, 3, 4, 5, 6, 8. Let's also remove the y-axis. So we have here to be 1, 2, 3, 4, 5, and 6. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Let's begin the plotting. Starting from A, 3, 1. Are you following? Yes. 3, 1. So we have 3 here, 1 positive. So we have it here. Then we have 8, 3, 1. Then B, 1, 1. So we have it here, 1, 1. That gives you B. Then C, 1, 1. I don't know where 1, 5 is. Someone can go. So currently, what's the 1, 5? Okay, continue. So there's our triangle. This is our triangle. Make sure you have the same triangle in your calculator. And look at what they are asking us to do. You finish crossing, then we also look at what they mean by describe. Yes.
And
Okay, so let's look at the straight here. So after I've been able to plot all our coordinates, they ask us to do what? Describe our figure. That's the space we are crossing. So with the technical eye, the other time I was telling you, you can't figure it out there, but with what we have here, it looks like something. So what type of triangle do we have here? Very good. Yeah, downward. So we have, because of the heights that we have been able to draw from this particular triangle. So we have, if I don't show the right hand side, the symbol inside this, don't show it here. So we are going to write it in the word description. So for the answer for I, we will describe the triangle to be the triangle. So we have triangle A, B, C, is right angle triangle. That is it. We have described it. Let's move on to the second lesson. I hope you understand why I named this right angle triangle. Because of the common features we have looked. We have identified on that triangle. Let's also look at the question here, find the equation of is it a line or a point? It's a line because they are combined 3 points, and 3 points was a line. Good. So let's focus on the 2 points AC. So let's first write our points down. The A gives us 3, 1, and our C gives us 1, 5. So we need to apply the equation of the line by bringing out the general equation of the line. So the general equation of the line is defined as. So let's say it together. Ready, go. Since you can recall rules or formulas like that. So this is the general equation of the straight line. General, surface, worldwide, everywhere you go. I need to understand the names of the variables that have been provided. Now let's look at something here. We can identify y1, x1. We are going to be placed by our points, the coordinates that we are going to use. Then we can also see our m, which mathematically we call it what? Gradients. So we need to find our gradients. Already the points are already there. You can choose any one of them to work with. But our gradients must be found before we can make the equation in. So let's first find the gradient. So our gradient m, so we have this gradient m is equal to
Nacho, thank you so much. Thank you. We appreciate it, okay?
S. So that means y2 minus y1 over x2 minus x2. So where will our x1, x2, y2, y1 minus y1 is 1 all over 1 minus what? Decide to choose point A. Okay?
Hi, Vidavis.
Then umbrella here. Decide to choose point C. All against a common gradient, negative 2. At the end of the day, you are going to get the same equation. True or false? Let's verify. You can't say true without verifying. So, Joseph, come and show our work. Your work. One say against the grading, negative, find your equation, substitute appropriately, and work out to get your equation. You can write the final equation in the slope form. I hope you know slope form. Whereby you make y a subject. Or you can equate everything to zero. That's the standard form. Are you okay? Okay. Oh, let's bring it to the line. So you get the equation to slope form. Your own, okay, your own should be in slope form and standard form at the same time, okay? Here's your point. Only give us the kind of equation you want, but we want to compare it to Joseph's one. So you should rather give it in the slope form. If you can also write it in the standard form, fine, but I want it first in the slope form. Are you like look at the gradient, so hello. I'm talking to African ladies. I'm gonna look at the gradient. You can't go back. Look at the gradient. The gradient. The gradient. The gradient. You guys see it? Our friend side is like me. Okay, let me help you. So our friend is still working. Okay, it's okay. Let's visit the person and see how well would know the neighbors inside. Thank you. Let's look at the two equations. So we have the general equation of a straight line. Then we start to work out with different words, points using the same gradients. So we have the points 3, 1. The 3 for the x. So correct substitution. So let's see the expansion of the bracket. This will give you negative, this will give you positive. Okay. Then we have here to be, this is also correct. Alright, let's go to the second one. So correct substitution, the points are 1, 5. So the 5 for y and 1 for we have this correct. Then let's look at the expansion. This is negative. This is what? By the positive period. Yes. So is there any mistake? No. Okay. Then what again?
Last time.
Okay. Now this is where the mistake comes in. See, whenever you are making sometimes, like you don't see clearly, like sometimes don't see clearly. And that's how we do it. So let's make a correction here. So we make y a standard, so over here I'm negative 5 by 7 to the other side, it becomes what? 5. And that will give our constant to be positive 7. And we still have the same as what we have, right? So that tells you if you are able to determine the gradient, any of the two given points can be used to determine the equation of this line. Are you with me? You get the same equation. Let's continue the question. We are not done. We have not answered the other. So the third question is saying that draw the image of the triangle A prime, or let's say A1, so A prime, B prime, C prime, which is the image of the original triangle ABC. Then the rule under the reflection in the x-axis when A map to A1, B map or A map to A prime, A map to B prime, C map to C prime. Then also indicates clearly the coordinates of the image. So let's do the calculation for the image. Then you cross them. Then you are done with this question. Are you okay? Yes. So let me believe the question is on. Look at I hope you have the point already. You have the point already. Look at it. So working with the third question, so the rule given is reflection in the x-axis. Is it x-axis? Yes. Okay. So let's take the rule. So x, y, okay. So x, y, map to x, negative y. Yeah, we are building on this rule to derive all the image for the correct points. Starting with the first one, A. And A was was what? 3-1. We have 3-1. Mapping onto A prime to what? Look at the format here and into the arrangement. 3 negative 1. Capitals. B map to, so B is 1-1. So map to B prime, that is 1. Thank you. And C is 1-5. Also map to, okay, for this one here, you are having to do all the process for me. So if I give you a marker, you close the first one to set up. Then after the time will close, and somebody will come and draw a line. Draw a line. Somebody will draw a straight line. Set up. So all the lines are being drawn. Yes. Yes. Come and plot the image for A. Then plot the image for B. Take it. Yes. So now I just so one after the other, she is not the second person. So come, where you are, you take time to focus. Thank you. So the second person should come for me. I hope you're okay over there. Okay. Oh, check the marker. Use the marker.
It could break. Like, I'm just waiting.
Thank you. See. We can proceed. Thank you. Okay. Alright, so it is left with the drawing of the line. So connect A to B for me. A to B, use my ruler. Don't use a finger. Connect A to B. A to B. Don't go me. A to B. Come for it. Come for it. We are celebrating. Come and join the line. Use my ruler. Then give the C. Take it. Give the C. Okay, the next person. B to C, yeah. Now it's not A to C. Okay, A to C. A to C.
Jessica.
A to C. A to C. This is other nice. Thank you. Now let's have something here in our diagram. And also take notes on this. Okay? Open your eyes clear. Look at what we have here. We have coordinates, the image of coordinates A, B, and C. But we can see that when we were asked to do what? Indicate clearly the coordinates, that's what we have done. But when we are indicating the coordinates for any figure drawn, make sure you don't write inside that figure you have drawn. Okay? That's why it's an apprentice, so you can put it right outside. So we can see from the triangle that we have here. Okay, so the coordinate B is found inside. That is not appropriate. And also the coordinate A is found inside. So you can see from the first one, everything is outside. So we have to just claim this and write it outside. So it was what? B, 1 negative 1, right? And this one is B prime. We like to say, apart from that, where is the B? Oh, okay. Okay. Is that A or B? This is A, right? And I wrote A and I'm saying B. Which one? The prime. Oh, you have good eyes too. And which one again? The A prime is here. Thank you. For the one, the first one has to look for the relation, that's the translation. That one, you first do the first one, and if coordinate was outside, then the second one has to be also draw. The coordinates were also outside. Just that it entered the first one. That means the one that entered the first one, that coordinate wasn't for it. So it is different altogether. So if I draw something like this, so let me spoil it out. This is the first one, and I have my coordinates labeled here. A is. In case I will draw another one, and it ends here in the middle. So where is my coordinates here? Where will it be? It will be inside. But inside doesn't mean it is the one that we have drawn. Okay? Are you feeling? Thank you. So we have answered the question successfully. Now let's talk about rotation. So we are going to do rotation. Can I clean a board? Yes. Okay. Now you are going to do the formula by yourself. I hope you know the formulas. Okay, so whether you know it or not, you are going to tell me the formula. Using Cartesian plane. So let me bring our coordinate and lines, draw it again to the normal form. So I'm dividing it into 2 equal parts.
And the key fingers.
So testing is also under ready motion. So we have looked at translation and what? And what? Reflection. Now rotation. We are going to look at the complex rotation. Let's learn the formula ourselves. So always we are beginning our first coordinate from the quadrant that gives us positive coordinates, right? So that is what we can see from the blackboard. Let's understand the meaning of rotation before we begin our experiment. What is rotation? What is rotation? Yes. What is rotation? You see, in this form of question, you can answer a scenario or direct implication. So any form of the answer is accepted. So scenario means creating a story or real life situation to explain the concept of what rotation or direct implication is also accepted. So which one are you giving? Yes. Moving about my own address. Okay. So if I am sitting on the floor, then I use my buttocks as my address. Then you going around. So I am rotating. I am rotating on my own address, and my address is known as buttocks. Right? Good. Let's use the floor. You open, you close. You move it from one direction to another direction. And the other that we are talking about for the door is to be the hinges, right? Okay, any other form apart from that. Those two, and that's what they are doing. So that is the concept of rotation. That is the concept. Alright, so let's apply this language so that we'll be able to use to solve for problems relating to the direct questions or graph-related questions. Alright, let's look here. So we are rotating. Okay, so this will be my ruler. So this is the ruler. When they ask you rotate the ruler, turn it upside down. This is the ruler in the original position. Rotate the ruler, turn it upside down. You continue to do that, so they ask you to stop. But let's look at the direction where we are going to perform this rotation concept. It is normally taken from the what? Anti-clockwise direction. Okay, from the opposite side, the opposite meaning of the floor. So rotations are taken from the anti-clockwise direction. So let's take the formula names, put up our experiment, and our formula is to describe the axis to the name that we're going to take down. Are you okay? So we have the first formula, rotation to 90 degrees anti-clockwise. Or 270 degrees clockwise. So our formula will be SY. Waiting for our result and adequate. Let's come to the second one. Rotation through rotation through 180 degrees anti-clockwise or half turn. So we explain why it is half turn. XY maps. So. The last one, the next one is number 3. Rotation through 270 degrees anti-clockwise or 90 degrees clockwise. So now one, two, we have the form XY map to. Okay, so we also have the fourth one here. Rotation through, so rotation about points. Okay. About point AB other than the origin. Okay. So this one has this format to talk about. So let's look at the first 3 proof to the rules that we are going to apply to solve our problem, and the fourth one also to add it. Let's come on to our XY line or the activity and perform activity. So we are talking about rotation, so let's do it together. Our point being is XY, and we are taking it from the anti-clockwise direction. That means from this direction. Are you okay? So if from this direction, then the immediate quadrant that you have here is the 90 degrees. Okay, so you have here to be called 90 degrees, and then that direction is called what? Anti-clockwise. So 90 degrees anti-clockwise. Now, you can see from the board that it has the other name 270 degrees clockwise. So if you also read the direction from the clockwise position, we are also going to read different degrees. That degrees is being measured in the clockwise. Okay? So over here, taking it from the clockwise direction, this gives you the immediate first 90 degrees. Are you okay? Yes. Then we move on to 180 degrees. Then coming up to the position of the 90 degrees of the anti-clockwise, that's also generated as what? So the accumulation of the 90 degrees that you have to move, that's the what? 270 degrees. Do you understand what I'm doing? Yes. So right here we have 270 degrees for clockwise. So I'm giving you these 2 names just for you to be aware that in a given question when you are being asked to use the name to take through the given point 270 degrees clockwise. Don't raise the hand and say that we don't rotate clockwise. They want you to know that 270 degrees clockwise, they are referring to the 90 degrees anti-clockwise. So use that appropriate formula and apply it carefully. Do you get it? Alright, so let's continue with our naming. So if this place is 90 degrees anti-clockwise, it is also named as what? 270 degrees clockwise. Let's come to the second place here. Now, over here, so we are adding up the clockwise and reducing anti-clockwise as we are moving around. So this one gives you the anti-clockwise, and it is 180 degrees anti-clockwise. The names are very important so that whenever you are applying the formula, you sure about the one that you are using. And let's come up to the clockwise direction. So when it is also taking to the clockwise direction, you have to know that this place is still nice. Coming to this place will give you another word. 180 again. Okay, so from the anti-clockwise, we get 180. From the clockwise, we still get what? 180. That is why we call it what? Where is this? Oh, I just looked half. It is called what? Half ten. So even if you pass the anti-clockwise direction, to give you the same answer as you pass from the clockwise direction. So that is the half ten. Are you okay? Okay, so we have the name 180. So let me make it the half ten. So over here is half ten. Let's come to the last rotation. So over here, so the appellation of the anti-clockwise. So if it is 180 plus 90, we get what? 270 degrees anti-clockwise. And if it is coming from the clockwise direction, what do we do? 90 degrees clockwise. So near other formula giving what show the formula is still the same. That's why over here I'm giving two names. Either 270 degrees anti-clockwise or 90 degrees clockwise. The formula is the same. Now on to the formula. Let's start our rotation. We have our names there. So we need to apply our experiments. Starting with the XY. Now, so my X is here, my Y is here. Let's turn it upside down. Which one will come on top? At this place, like Y, and X is what? Down. Alright. Let's finish all the rotation and look at the operation at the Let's rotate this again. Which one will come up again? So we have X and Y will come down. The last rotation. Y. So Y will come as X. Now, the operations are each of the programs determine the nature of our image. Okay. Let's come to the first rotation. Now, at this point where it is 90 degrees anti-clockwise, we have the x-axis to be what? Negative. Look at where it is. Although I have not named this, so let's put the negative, positive, positive, negative. Everything that we write there are negatives or positive. So we have this word negative. So the x-axis at this particular quadrant gives us what? Negative. Then our y-axis at this quadrant gives us what? Positive. So as we have to apply the appropriate operation for the x and the y. But that doesn't mean I'm saying this x-axis is negative, so we are supposed to add negative to the x. No. You know the application of quadrants. So application of coordinates. Coordinates. The coordinates are being expressed as what? X, y. Okay? Yeah. So no matter the number that comes first, it is still for S. So if I write neutral and I ask you what is the X coordinate, it is what? P. So if I have YX and I still ask what is the S coordinate, you will tell me X again. If the first number is what? Y. So we are going to look at the first number is standing for what? X. The second number is standing for Y. Unfortunately, it has been the opposite way of their names, but you have to be vigilant and know that you are doing that right. Are you okay? So since our X axis is x-axis. Hello? Can you hear me? Yes. Okay. So since our x-axis is negative, we apply one negative to our first number, not that x that you see there. Do you get it? Then what happens to the second number? The second number is for the y-axis, and it is already positive, so don't add anything to it. Let's come to the second rotation. We have our 180 degrees angle clockwise, right? And for that particular quadrant, all the two angles are negative. You can see that. And with the first coordinate that you see is x. So whether it is x there or not, it is still presented what x. But unfortunately, it is the x itself. So we have it to be what? Negative y. So let's finish with the last one. Let's finish with the last one. We have the last rotation. Look at where it is now. So for this particular quadrant, we have the x to be positive. That is the first number to positive. The second number to be negative. So we have the second number to be negative. These are our formulas. Let's come and write them in place of their corresponding names. Starting from here. So rotation 290 degrees anti-clockwise or 270 degrees clockwise is giving us not over. Say it again. Negative yx. Negative yx. So we have here negative y positive x. So here you have the formula. I am ready for you. Let's dive together from the right. Yes. Okay, so let's look at the second one. Look at the second one. For the half turn, what is the formula related to the half turn? Negative x, negative y. And for the 270 degrees anti-clockwise, what is its formula? Negative x. I'm reading the position so that you follow the rule and answer questions and errors. So first, under point number 4, okay, subtract the center of the rotation from the given point. Write it. Subtract the center of the rotation from the given point. Subtract the center of the rotation from the given point. And it goes with this expression, with this point regression. Add this one to it. Are you following? Yes. If a given point is xy and the center is given as AB, so the expression that says the subtract the center of the rotation from the given point is given as that is x minus a y minus b. This is the expression. So as we have the point given point named xy and a center has already been given in your question, subtract that center from the given point. Okay, that's the first rule. Let's move on to the second rule. Can we move on? Okay. So we have second rule. Apply the appropriate rotation formula. Right? Apply the appropriate rotation formula. Apply the appropriate rotation formula. They will surely, don't act what I'm saying afterwards. They will surely give you a specific rotation formula, the name. Okay, although we are not rotating from the point of origin, they will still be giving the direction where the rotation will go. And this direction will come from any of these three. These three are always there, they are standard. Okay, so although they are giving you the person in the first form, they will still give you the specific location you should move to. So what you do is, after they are giving you a point which is not from the origin, you have to subtract that point from the giving that center to the given point. You will surely get the results. That particular result you are going to derive or get Apply the appropriate formula among the 1, 2, and 3 fields. If it is implementing these articles, please do that and get a new point or new point. That's the meaning to the points on the that is apply the appropriate equation formula. Then let's look at the points number 3, the final points. Add the results. Add the results to the center of the rotation. Add the results to the center of the rotation. Add the results to the center of the rotation. Add the results to the center of the rotation. You understand this point? So, after you subtract the center from the given point, you get a specific point, new point again. That specific point, you are going to apply the rotation direction to it, and you surely get a point again. That point is that because after you have applied the formula, go back and add the center to that new point, and that's your final answer. Are you okay? Yes. So when you get a practice on this, and this expression, the explanation I'll give it later. So let's take this one. So that is x minus a, y minus a will give you negative y. Then finally you have so this is the expression. You get the understanding better when you start with the example. Let's begin with the graph example. So keep the formulas in mind when we need them to call for me. Okay. So let's try this question. Yes. Okay. All right. Let's try the question.
It's not reaction like this. Take this video something is happening.
Please keep quiet.
He's a millionaire at very young age. What time would it allow you to do? That's a pretty big space. Okay, so what we are about to watch is what is happening
I hope you are right. So that's our question. To finish writing the question, then let's look at what the question is demanding us. Right past. Just a minute more.
Hi, Emmanuel.
Okay, let's start. So let me claim what you have on the board. Let's do it together. Are you ready? So using a scale of 2 centimeters to 2 units on both axes, so we're talking about the X and Y. Every big box you are going to number with the intervals of 2, 5, 2, 4, 6, and so on. With the given ranges here. So for X axis, start from -8 to +8, and the Y axis start from -10 to what? +10. They indicate clearly all the coordinates, the vertices and the coordinates. Then on the triangle P, QR, with the following points, the vertices and the coordinates are the vertices. Yes. So that's the first one. So the A and B. Let's draw our. So according to the range given to us, we need all the negatives and the positive portions from our given axis. That is for the X and for the Y axis. So which means we divide the graph into equal parts. Make sure you close all the points with arrows. And then you label it OS and OY. Then your origin, you just write it there. Let's begin with the numbering of the axis. So let's start with the X axis. So -8 to +8. And we are using the scale 2 centimeters to so now let's start the positive side. Then for the Y axis, 2, 4, 6, 8, 10. -2, -4, -6, 8. All right. Let's answer the question B5. First, we need to plot the vertices given to us. B, Q, and R. Are you following? Yes. Okay. So the coordinate for P is what? Negative. Okay, so in fact, negative traces, you can see. But please for me, so that my eyes in fact, start the let's give you all the points for the P, Q, and R. Okay. Okay. You come and draw the line for us. Yes, come. So, plot points P, -3, +6. They're not done. Don't do this subject. Then the point skill. Give it to her. -1, +1. The next one. Positive for positive 2. Let's clap for her. Let's clap for her. Yes, we need to just come and go there. Line. Joanna. Where is Joanna? Where is Joanna? Oh, Joanna. You must complete our triangle for us. So, from A to B, B to C, then close the other parts. Okay, the first one, the second one, repeat it. Yes. Please keep quiet.
Hi, Mau. Yes, so this is Agri Memorial, okay, in Cape Coast. Agri Memorial in Cape Coast.
Okay, so right this outside. What for the podium? So that is P, right? The scale. -1. Okay, so that's the thing. Let's continue with the image. Let's continue with the image. That is the second question. Oh, we have a lot to talk about school. So,
Hi, Mau
fire
and Jana. Okay, so this is, I believe you didn't hear me earlier. So this is Agri Memorial, and the school is located at Cape Coast, okay?
no formula attached. Here's the whole thing. So why don't you call it like that?
Somebody is saying that they teach
So, hallelujah. So we are going to draw this because it is already been completed. So, keep trying.
What exactly do you want to know about the school? You can drop me your contact, then I will make inquiry, or I would look for the headmaster or headmistress, and the person will talk to you more about the school, okay? And I tell you, sis, the school it has a very serene environment for learning. Their students are very well spoken, they are calm, they're so nice, I won't lie. And I met a lady today, she said she's new, yeah, so it's senior high school. It's senior high school, yeah. So I hope your daughter or son is done with junior high school, because this is only senior high school, and it's a boarding school, okay?
So,
No, it's not. My mic is not working. It's not. It was connected them perfect.
Are you done? You have to drop the door.
I don't want to worry you.
What is it?
But they are listening to him. This ear is very sharp. The sounds are captures. So they are listening. Because they never say he's a good tell the teacher students to listen.
Are you done? Thank you.
I'm going to let him know when we are out for break, okay? Yeah, so for now, he's trying to break the World Guinness Book of Record by doing 40 hours teaching mathematics lessons. Yeah, so that's what we are on here for.
Alright, so that is it. You see, we have the 10 person here. The images, annual rotation, do 180 degrees. About the origin means anti-clockwise, okay? Okay. Whereby P map to P, 2 map to P, and R map to R. You have 5 minutes to do that one for me. Your time starts now.
So share this live so it can reach other people. Yeah, we're trying to create awareness and we need your prayers. Yeah, he really needs your prayers for God to give him the strength to carry on because he's about to take this. He's about to take it from a Nigerian. Okay, so let's take it from him. We have to bring it home from Nigeria. Okay, it's mathematics, okay? Okay. So he's teaching math. It's math. She's also a math teacher. She's also a math teacher. She has a degree. What topic is he teaching right now? Okay, rigid and motion. So he's teaching rigid motion. Rigid motion. That's the topic he's teaching right now.
2 minutes.
Yeah, ma'am, you cannot see well. Let me
Yeah.
see. Okay. Can you
Yeah.
see now? Please, ma'am, can you see now? Okay, you can see now.
Let's prepare answer. Going to put it on the board together. You must take it. I mean, they are. Look at this. From the beginning, it said, draw and label clearly all the X's and the holes. Label clearly. And that is the key. Taking effect to the I, and the I. Okay. So let's say our result. So we're being asked to solve the third one, right? We are supposed to use the particular formula applied to get the image in the plot step. So let's start beginning with the formula. Beginning with the formula. You'll start to go and show working to get all the images for the T2, Q2, and R2. Then we also continue as well. Why is all two? Please write the name of the company before you
every time, even if nuclear
No. As you have been a formula for us, find all the images for the third one. That's what I
advantage normally use and example. So it's same as
Then to let's go ahead. Thank you. So rotation through 180 degrees about the origin. Is the formula correct? Yes. Okay. So the points, the set was from Q to, so where is Q? -3, positive 6. Okay, so okay, so the points are correct. You are just going to cross the just cross. You will join the lines. These are the points.
is it the same person?
Oh no! These people, this student that you are seeing, they are very bright. Oh man, I've not seen people who are this intelligent like them. Oh. They are all good.
We are in our last hour of activity for this particular lesson. So surely very soon go for break. All the three. All the three. To B, Q, and R. Look at them.
Yes, ma'am.
That's right.
Oh, sorry. Are they? It's into another one. So let me there. Which one? How about the marker test? Okay, which one? one negative one or yes, one. Where is the one negative one? So where is one? Where is one? One is one. Negative one. So I feel here. Which one? Negative 4. No, negative. Negative 4, negative. So, okay. Negative 4, negative. Yes, yes. This negative. Thank you. Let's clap for him. Thank you. So where's the first one? And the third. Okay. Is that the right place? Okay. Now wait, so question is what? One negative one. So you have to realize one. And this one says negative 4. Negative 8. It is 3 negative 6 this time. 5. 3.
They are business students, okay? Business students, and this is mathematics. He's teaching only math. Yeah.
This is my. Yeah, this is a point though. This is a point. And the negative 1, very good. So let's change the coordinates. It is 1 and negative 2. So that is 1 negative 1 here, right? Very good. So that is still 2. 1 negative 1. Yes. Now let's plot or let's draw our what? Lines. Points for us. Can you see? Wait, this is P2 out. So after drawing and the voltage has been defined inside. Try and limit the writing outside for us.
I can't say anything about that because we are just here for this event, okay? I can't say anything about that. But I can help you inquire.
I'll look at it before trying to write. Very good. So we are gotten our third triangle. Alright. Let's look at the last aspect of the question. Question C. Have you heard of single transformation before? Okay, then let's do it together. So, okay, I said, what. We have a relation here. Look at this carefully. We have triangle B, they are being compared to the triangle P2, Q2, R2. The second transformation that they are talking about is the formula or rule that they have used to relate these two given triangles. Are you okay? The rule that they have used to relate these two given triangles. So we have the first triangle E, Q, R, which format or which rule was being used to be given in the another triangle or in the image of that given triangle that they are using to P2, Q2, R2. So the formula. And the formula that we are talking about, we do personally we don't do. Unless we do something before we get to the formula. Okay, and it can even come from reflection, it can come from rotation. Any formula that we are talking about can be one of them. Do you get it? So let's do and see the formula that can derive from the relation directly. So let's write the rule as it is. B triangle B to R onto triangle B2, Q2, R2. So we are going to use the points that we have already derived and relate onto each other. Okay, it's just like mapping. Okay, relate onto each other. So start from the main triangle, the coordinates for the P. So for P, it was given as what? The P was given as negative 3, 6. Map onto B was 2. Let's also look at the formula for B, the coordinates for B. That is what? 3 negative 6. Let's come to the second one, Q. The coordinate is negative 1. And the Q2 will be 1. The next one, R, which is 4, is being mapped to R2, which is what? Negative 4, negative 2. Look at this relation on the board. Just compare what we have. So this is our analysis, okay? We are taking this to be our original point. Watch carefully. For us to get the formula, these are some of the deductions you must do for you to know the exact formula to use. And even if it is the name of the formula they want, that is simple composition. Okay? So we are going to make this as our original point x1 map to let's compare the relation. Watch here. From the points that we have been deriving here. See this, look at the difference between the points B and points B2. We have the x to be, so how come the x negative 3 changes to positive 3? So what happened to it? Which means The formula that they use, X was negative. That's true.
Yes.
Let's prove it with the second one as well. Then we have the same thing here. We also compare the X, the term to the Y. Okay. Then this one to the original point has changed to our new point. So we have the difference. So there's negative one, and we are talking of one as well. The image. So which means X was what? Negative. And even this one tells us that X is positive, but over here X is what? Negative. So we are going to put negative to X. At the end of the day, to give you a specific formula, a rule. Okay? Let's come to the Y. Let's come from here. So Y is positive at the original point, but Y is negative at the image. So Y is negative, right?
Yes.
And the same thing applies to the second one. Positive at the original point and negative at the image. So Y is also negative.
Yes.
The same thing. So Y is also negative. So what's the name of this? What's the name of this one? Sample. So as you are able to compare their differences, you should be able to put them into a relation form, SY relation form. Then when you are able to do it, then you can therefore say that. They said what single transformation? So you are going to say that the single transformation. The single transformation is the rotation through half 10. So I will decide it. I will choose the name half 10. Are you okay?
Yes.
It is the name of the formula they want. But before you get the name of the formula, okay, possible. You are trying to thank you. Don't give you mine.
Yes. Even.
Okay, so I'm saying that since S1 maps to negative X negative 1, can you say multiplication by scale factor negative 1?
Yes.
Wow.
When I apply the E against E, 0 against E, you do it now. And that can also be central transformation. Are you okay? Very good. Alright. So that brings us to the end of this particular question. Okay? This particular question. Are you okay?
Yes.
What are you expecting? Okay, so let's move on to enlarge. Yes.
Okay, Amao. What?
And
Okay, I mean Amao. Let me know if you're still here so I can call my number for you, okay? Because as it is right now, I can't see any number on here, so I can only call mine. Let me know if you are here. Let me call my number.
So whenever there is a given coordinates, and you want us to perform a given transformation in this coordinates. They can also be given a specific skill factor
Yes.
so that we can have it corresponding, and that particular skill factor will lead to the concept enlargement. Okay, let's look at a sketch on how enlargement looks like. Then we apply this in our question that we solve. So imagine we have, let me give out any points that I can give you a sketch. Enlargement of the origin. So let's start giving points. X, 2, 1, y, 4, 3, and 6, 3, 5. With skill factor. That was something here. So as our sister was talking about skill factor, goes into the concept of the enlargement. So it has the formula. So the formula for enlargement, that is xy mark 2. So let's label this. The highest number on the x-axis is what? Just look at it. The highest number on the x-axis is 8. And the highest number on the y-axis is positive, right? Yes. Okay, so we have this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. So we have our skill here. Let's plot the first point. The x is 2, 1, 5. This is 2. 2, 1 here. This is sketch. You don't want to do another. So 2, 1. That is our x. Just write the x. Then we have the second one, y. 4, 3. So we have 4, 3. 4 against 3. Yeah. Okay. Then we have here to be y. And the last one, 3, 5. 3, 5 will be here. And that is our text. So we have to form a triangle with this. Okay. And also plot the image. Let's do the image. 4, 2. 4, 2. Here. 4, 2. And that is x squared. Then 8, 6. 8, 6. 8, 6. Down. Okay.
Yes.
Okay, so we have it to y. Then system. 6, 10. 6, 10. Right? Like it here. And That is it. Fine. And I'm going to complete the triangle for that one. Good. Look at what we are going to do. We are going to demonstrate the enlargement of the points of origin. Okay? So after plotting everything, we are going to extend the line from the point of origin to their corresponding vertices from the original point to their enlargement point. Okay, their images. So look at. So we have X mapped towards X prime from the point of origin. So everything will done from the origin through the points. So that is for S. Let's do same for Y. This is Y, this is Y. So also from the point of origin. Okay, this is not still, so it's not under skill. So we'll start to manage. Okay? Okay, so which means the point has to be here. So okay, then I was set. That's the half word. Yes. That's the half. It has to be half. Let's do this. Okay. So we can extend the lines. So we are just going to take the enlargement from the point of origin. So after we draw the original point and its corresponding features, draw a straight line from the origin throughout the corresponding lengths from X to X1. We just extend the line from Y to Y1, from Z to Z1. And that is the meaning of the enlargement. Yes. It depends on the kind of question you are going to do. Okay. So as we have stated here from the point of origin, enlarge this from the point of origin. When we finish drawing our triangle, then you extend the lines from the point of origin. Do you get it? Alright. So this is just a sketch to demonstrate that. Now let's look at, so you know the formula, right? Let me complete this formula. I've even used to find the coordinates for this point. So what strategy we is we multiply the k against the x and the y, right? So this one will give you kx over, I said over, kx and what? K1. Good. And this is the formula for enlargement for using a scale factor. Alright. Let's also look at one aspect of the enlargement. Enlargement from any points other than the origin. So this time, you see, we have demonstrated the enlargement from the point of origin. We have another one that also talks about enlargement from any point other than the origin. Which means that the enlargement is not take place from the origin. So let's look at that one. Can I do it, please? Okay, so I'm going to give you the steps and use your person for it. So, write the